Tonight, as you settle into the comfort of your bed, feeling the solid support of floor and foundation beneath you, take a moment to imagine something extraordinary. The very ground that holds you so steadily, so faithfully, is not as still as it appears. Beneath your resting body lies one of nature's most magnificent secrets, a sleeping giant that has been moving, breathing, and dancing for billions of years, carrying you and everything you know on an endless journey across the face of the earth. Your bed feels motionless, your room seems perfectly still, yet at this very moment, you are traveling. Not just through the familiar rotation of day and night, not just in the Earth's orbital dance around the sun, but in something far more ancient and profound. The continent beneath you, whether it's North America, Europe, Asia, or any other vast landmass, is drifting across the planet's surface like a sleeping whale moving through the deepest ocean. This movement is so slow, so gentle, that it cannot be felt in a human lifetime, yet it is as real and constant as your own breathing. Imagine the Earth as a living thing, its surface like skin that stretches and wrinkles, tears and heals. But unlike your skin, which covers muscle and bone, the Earth's surface floats upon something far more mysterious and powerful, an ocean of rock so hot it flows like honey, so deep it extends nearly halfway to the planet's core. This hidden sea of molten stone has been moving in slow, majestic currents for longer than life has existed on Earth, carrying the continents like sleeping children on its back. The ground beneath your home, beneath your city, beneath your entire country, rests upon enormous pieces of this rocky skin, what scientists call tectonic plates. Think of them as puzzle pieces, but puzzle pieces that can move, collide, separate, and slide past one another with the patience of geological time. These plates are not thin like the skin of an apple, but thick like great stone rafts, some stretching for thousands of miles in every direction, reaching down into the earth for dozens of miles before touching that flowing, molten sea below. Right now, as you breathe slowly and deeply, your continent is moving. It might be drifting toward another landmass at the speed your fingernails grow, so slowly that mountains have time to rise and fall, so gently that rivers can carve canyons grain by grain. Or perhaps your piece of the earth is pulling away from its neighbors, creating space for new ocean floor to bubble up from the depths like dark bread rising in an oven. The movement is so gradual, so measured, that it seems like stillness, yet it is the most powerful force shaping the world you know. This ancient dance has been choreographing the face of the earth since before the first storms gathered, before the first oceans filled their basins, before the first spark of life flickered in the darkness. The continents you see on maps today, Africa, South America, Antarctica, these familiar shapes are just the most recent arrangement in an endless waltz of stone. They have been partners before, separating and reuniting across hundreds of millions of years, their edges remembering the touch of former neighbors in the matching curves of coastlines and the identical fossils found on opposite sides of vast oceans. The engine that drives this magnificent choreography lies deep beneath your feet, in the Earth's molten heart where temperatures soar hotter than the surface of Venus. Here, in chambers of liquid rock that dwarf any ocean, tremendous currents rise and fall like the breath of a sleeping god. Hot material rises toward the surface, cools, and sinks back down again in cycles that take millions of years to complete. These thermal currents, flowing through rock as thick as honey, push and pull on the great stone plates above, nudging the continents along their predetermined paths across the globe. As you lie in your bed tonight, feeling the familiar weight of your body against the mattress, remember that you are part of this ancient story. The calcium in your bones was once part of ancient sea creatures whose shells accumulated on ocean floors that no longer exist. The iron in your blood was forged in the heart of a dying star and later swept up in the formation of a planet that has been reshaping itself ever since. You are not separate from this geological dance, you are part of it, made from it, carried by it through space and time. Your house sits upon rock that might have once been at the bottom of a tropical sea, or high on a mountain peak, or deep in the Earth's interior where diamonds form in the crushing darkness. The story of every grain of sand, every pebble, every boulder is a story of incredible journeys across impossible distances, of transformations that turn mountain peaks into beach sand and ocean floors into towering ranges that scrape the sky. This is the world you inhabit, not a static, unchanging stage, but a living, breathing, moving theater where the grandest drama in the solar system has been playing out for over 4 billion years. The ground beneath your feet holds the memory of ice ages and tropical paradises, of continents colliding with the force of cosmic impacts, of new lands being born from fire and time. Tonight, as your breathing slows and your body settles into rest, let your mind wander down through the floors of your building, through the soil and bedrock, down into the hidden realm where solid rock flows like water and time moves like honey. Here, in the deep currents of stone, lie the rivers of fire that will carry your dreams toward tomorrow's dawn. As you drift deeper into rest, let your awareness descend with you, sinking through layers of consciousness just as warmth sinks through the layers of the earth. Far beneath the solid ground that cradles your sleeping form, in chambers so deep that sunlight has never touched them, flows a hidden ocean unlike any water you have ever known. This is an ocean of liquid stone, of molten rock that moves with the grace of honey and the power of hurricanes, carrying within its currents the very forces that shape the world above. Imagine, if you can, rivers that flow not with water but with rock heated to temperatures that would melt steel like butter. These are not the quick, chattering streams of mountain valleys, but vast, patient currents that move through the Earth's interior with the measured pace of geological time. They rise and fall, circle and spiral, in patterns so grand that it would take millions of human lifetimes just to watch one complete cycle of their flow. Yet flow they do, and have been flowing since the Earth was young, carrying heat from the planet's fiery core up toward the surface, then cooling and sinking back down again in an endless circulation that has never paused, never rested, never stopped. These thermal rivers exist in a realm called the mantle, a thick shell of hot rock that wraps around the Earth's molten iron heart like a blanket made of flowing stone. The mantle is not quite liquid and not quite solid, but something in between, a material so hot that it behaves like an incredibly thick fluid, plastic and malleable under the enormous pressures of the deep Earth. Think of warm honey on a winter morning, or thick syrup poured slowly from a pitcher. This is how the mantle moves, viscous, continuous, inexorable. The heat that drives these deep currents comes from the very center of your planet, from a core of iron and nickel so hot it glows like a captured star. This inner fire has been burning for over 4 billion years, fed not by oxygen and fuel like the flames you know, but by the slow decay of radioactive elements that have been releasing their energy grain by grain since the Earth first formed. It is the same process that powers the sun, but buried deep beneath your feet, creating a furnace that will burn for billions of years yet to come. From this central fire, heat rises through the mantle in great plumes and columns, like smoke rising from a campfire but made of molten rock instead of air. These rising currents of superheated stone carry with them the patient energy that moves continents. As the hot material reaches the upper layers of the mantle, it begins to cool, becoming denser and heavier until it eventually sinks back down toward the core, making room for more hot rock to rise behind it. This is convection, the same process that moves air in your atmosphere and water in your oceans, but here it moves stone, and moves it for millions of years at a time. Picture these mantle currents as you might imagine the Gulf Stream or other great ocean currents, but flowing through rock instead of water, and taking not months but millennia to complete their circuits. They form enormous loops and spirals within the Earth, some so vast they stretch from one side of the planet to the other. Where these currents rise, they push up on the rocky plates above, creating the forces that build mountains and open new ocean basins. Where they sink, they pull down on the surface, creating the trenches where ocean floors disappear back into the depths. The continents above, including the one that holds you now as you rest, ride upon these thermal currents like leaves floating on the surface of a slow-moving stream. Africa drifts northward on one current, while South America rides another westward. Antarctica circles the South Pole on currents that isolate it in cold, while Australia journeys northward toward Asia on thermal rivers that have been carrying it for 50 million years. Each continent moves to the rhythm of the deep currents beneath it, dancing to music played by fire and time. These rivers of liquid rock connect every part of the Earth in ways that are both literal and profound. The same thermal current that warms the rocks beneath your feet also warms the rocks beneath a child sleeping in Japan, beneath a scientist working in Antarctica, beneath every living thing on the planet's surface. The Earth breathes as one organism through these deep currents, its warm exhalations emerging as hot springs and volcanoes, its slow inhalations drawing cold surface rock back down into the depths to be reheated and renewed. The time scale of these movements is almost impossible for human minds to grasp. The rock flowing beneath you tonight began its journey upward from the core when the first complex life was just beginning to stir in ancient seas. It has been rising slowly through the millennia, carrying its cargo of heat through stone passages that have never known light or air. By the time it reaches the surface, perhaps emerging as lava from a distant volcano, humans might have evolved into something unrecognizable, or the Earth itself might be circling a different star. Yet for all their incredible slowness, these deep currents are the most powerful sculptors of your world's surface. Every mountain range, every ocean basin, every island chain owes its existence to the patient push and pull of thermal currents in the depths. The Himalayas rise because currents beneath India are pushing that continent into Asia. The Atlantic Ocean widens because currents beneath the mid-ocean ridge are pulling Europe and America apart. The islands of Hawaii exist because a plume of hot rock has been rising from the deep mantle for millions of years, breaking through the ocean floor like a blowtorch cutting through steel. As your own circulation slows with approaching sleep, your blood carrying warmth and life through the vessels of your body, remember that you are part of a much larger circulation system. The same elements that flow through your veins once flowed through these deep rivers of stone. The iron in your blood was forged in the Earth's core and carried upward by thermal currents. The calcium in your bones rode these same deep streams when the world was young and no life existed anywhere on the surface. Tonight, as you surrender to rest, feel yourself connected to these ancient flows of heat and stone, to currents that have been moving since before the first breath was drawn by any living thing. Somewhere in the darkness beneath you, rock that was once part of the ocean floor is beginning its long journey back to the surface, carrying with it the memories of creatures that lived and died in seas that dried up before your species was even a dream. Close your eyes and imagine the world as it exists in your mind, the familiar shapes of continents spread across blue oceans, each landmass distinct and separate, divided by vast stretches of water that seem as permanent as the stars themselves. But what if you could travel backward through time, not in years or decades, but in hundreds of millions of years, watching the Earth's surface like a movie played in reverse? You would witness something extraordinary, the continents moving like pieces of a cosmic puzzle, sliding across the globe until they click together into a single, magnificent whole. Once upon a time so ancient that no human words can properly measure it, all the land you know was united. Africa and South America lay side by side like sleeping lovers, their coastlines fitting together with the perfection of two hands clasped in prayer. North America snuggled against Europe and northwestern Africa, while India rested far to the south, embracing Antarctica and Australia in a configuration that would seem impossible to anyone looking at a modern map. This supercontinent, which scientists call Pangaea, meaning all Earth, was a single vast island surrounded by one enormous ocean that stretched unbroken across the rest of the planet. But the Earth remembers this ancient unity, and if you know how to read the language written in stone, you can still see the evidence of this long-lost connection everywhere around you. The rocks beneath your feet hold memories as clear and detailed as photographs, preserving the story of when your continent touched and embraced continents that now lie thousands of miles away across impossible distances of ocean. Consider the eastern coast of South America, where Brazil meets the Atlantic Ocean. If you could shrink yourself down and examine the rocks there with the patience of a geologist, you would find something remarkable, ancient mountain ranges that simply stop at the ocean's edge, as if they had been cut by some enormous knife. But follow that same coastline with your finger on a map, then leap across the Atlantic to the western coast of Africa. There, in rocks of exactly the same age and composition, you would find the other half of those same mountain ranges, picking up where the South American ranges left off, as if the ocean between them were merely an illusion. The Appalachian Mountains of eastern North America tell a similar story of ancient connection and separation. These worn, gentle peaks hold within their stone the memory of when they were part of a much larger mountain chain that continued across what is now the Atlantic Ocean. In Scotland, in Ireland, in Scandinavia, you can find the other pieces of this once mighty range, mountains that match the Appalachians rock for rock, layer for layer, like pages torn from the same ancient book and scattered across the ocean. Even more touching are the fossils, the preserved remains of creatures that lived and died when the continents were united. In the rocks of South America, paleontologists have found the bones of Mesosaurus, a small reptile that lived in freshwater lakes and rivers nearly 300 million years ago. This little creature could not have swum across thousands of miles of salt water, yet its identical remains appear in rocks of exactly the same age in southern Africa. The only explanation is that when Mesosaurus was alive, South America and Africa were not separated by an ocean, but were part of the same continuous landmass, allowing these ancient reptiles to wander freely between what we now think of as separate continents. The plant fossils tell the same story with even greater poetry. Glossopteris, an ancient seed fern, left its delicate leaf impressions in rocks across South America, Africa, India, Australia, and Antarctica, continents now separated by some of the widest oceans on Earth. Yet these identical plants grew together in vast forests when all these lands were one, their seeds spreading on ancient winds across landscapes that knew no oceanic barriers. The fact that identical Glossopteris fossils appear on every southern continent is like finding the same handwriting in letters scattered across the world, proof of a connection that transcends the distances that now divide them. The rocks themselves remember not just what creatures lived upon them, but what climates they experienced when they were in different positions on the globe. In the heart of the Sahara Desert, geologists have found the scratches and grooves left by ancient glacier, evidence that this now scorching landscape once lay near the South Pole, buried under miles of ice. Meanwhile, coal deposits in Antarctica speak of a time when that frozen continent basked in tropical warmth, covered with lush forests of trees that grew and died and were buried to become the black stone that preserves their memory. Even the patterns of magnetism frozen into ancient rocks tell the story of continental drift. As volcanic rocks cool and solidify, they capture the direction of the Earth's magnetic field like a compass needle frozen in stone. By reading these magnetic signatures in rocks of different ages, scientists can trace the wandering paths of the continents across the globe, watching them spiral and dance and collide in slow motion across the eons. The evidence is everywhere, written in languages that the Earth itself has preserved for hundreds of millions of years. Salt deposits that could only have formed in ancient inland seas now lie buried beneath modern continents, marking the positions of vanished coastlines. Coral reefs that grew in tropical waters now rest as limestone in the hearts of mountain ranges, lifted high above the sea by the collision of continents that once lay far apart. This is perhaps the most beautiful aspect of the story written in stone, that separation is not permanent, that distance is not forever. The continents that drifted apart are even now moving toward new meetings, new embraces. Africa creeps northward toward Europe, slowly closing the Mediterranean Sea. Australia journeys north toward Asia, carrying with it the unique creatures that evolved in isolation during its long voyage. The Atlantic Ocean, which has been widening for nearly 200 million years, will someday begin to close again as new patterns of circulation in the deep mantle reverse the flow of the thermal currents beneath. Tonight, as you rest in your bed, remember that the ground beneath you holds these ancient memories, these stories of connection and separation played out across impossible stretches of time. The rock that supports your home may have once supported dinosaurs walking across landscapes that joined continents now separated by vast oceans. In your dreams, you might wander across Pangaea, watching the slow dance of stone and time that continues even now, as the mountains grow grain by grain from the patient collision of Earth's wandering pieces. As you lie in the gentle darkness, breathing slowly and deeply, imagine two enormous pieces of the Earth's crust approaching each other with the patience of ancient lovers meeting after eons apart. This is not a collision like the crash of waves against stone, or the violent meeting of storm clouds in the sky. This is something infinitely more gentle and infinitely more powerful, a convergence so slow that mountains have time to grow from whispers, rising grain by grain toward the heavens while the very atoms in the air have time to dance and settle between each microscopic movement. The birth of a mountain begins not with thunder and earthquake, though these may come later, but with pressure so gentle you could not feel it if you pressed your hand against the moving stone. Imagine the weight of a feather settling on your chest as you rest. Now imagine that same gentle pressure applied continuously, without pause, without rest, for millions upon millions of years. This is how mountains are born, not from sudden violence, but from the accumulated whispers of time itself, each moment adding its tiny contribution to a force that will eventually lift solid rock higher than eagles soar. When two continents meet in their slow dance across the Earth's surface, they do not simply bounce apart like billiard balls. Instead, they embrace with geological tenderness, their edges crumpling and folding like fabric pushed together by invisible hands. The rock at their meeting place, stone that was once perhaps the floor of an ancient sea or the edge of a peaceful plain, finds itself caught in this embrace, compressed and lifted, in a rhythm so slow that entire species evolve and vanish in the time it takes for a single fold to form. Picture the Himalayas, those towering peaks that scrape the belly of the sky, and know that they are still growing. Right now, as you settle into sleep, India continues its ancient journey northward, pushing into Asia with the persistence of a dream that refuses to fade. The collision began 50 million years ago when India, carried on its raft of thermal currents, first kissed the southern edge of Asia. That gentle touch has continued ever since, lifting the land between them grain by grain, breath by breath, until the tallest peaks on Earth now stand where once there was only a warm, shallow sea. The limestone near the summit of Mount Everest tells this story with crystalline clarity. That rock, now standing nearly 6 miles above the ocean, was formed from the shells and skeletons of sea creatures that lived and died in tropical waters when dinosaurs still roamed the Earth. Coral reefs that once basked in sunlight filtering through clear water now rest in the death zone of the world's highest peak, where the air is too thin for human lungs and the cold would freeze your breath to ice. Yet the tiny fossils embedded in that summit limestone can still show you the delicate structure of creatures that knew only warmth and light, preserved in stone that now touches the edge of space. This is the poetry written by pressure, the transformation of the soft and yielding into the hard and enduring, the lifting of the low places to heights that mock the clouds. The Alps rose when Africa nudged Europe, the Appalachians when ancient North America embraced a continent that no longer exists, the Andes when the Pacific Ocean floor dove beneath South America like a whale sounding into the depths. Each range tells the story of an embrace, a meeting, a slow dance of stone that plays out across the centuries like music too deep for human ears to hear. But mountains are not just lifted up, they are also folded, twisted, and sculpted by the very forces that birth them. Imagine taking a tablecloth and pushing the opposite edges together. The fabric between your hands will wrinkle and fold, creating peaks and valleys in miniature. This is what happens to layers of rock when continents collide, except that each fold may be hundreds of miles wide and thousands of feet high. Rock layers that were once as flat and level as pages in a book become curved and twisted, bent into impossible shapes that tell the story of unimaginable forces applied with infinite patience. Sometimes the pressure creates not just folds but breaks, where entire slabs of stone slide over one another like playing cards being shuffled by a giant's hand. Mountains can be built from these overlapping sheets of rock, each layer telling a different chapter in the Earth's history, older rocks finding themselves lifted above younger ones in defiance of the normal order of time. The Canadian Rockies show this process beautifully, where ancient rocks that formed in deep oceans now rest atop stones that were born in shallow seas, carried there on the slow-moving escalators of geological time. The heat generated by this crushing and folding can transform the rocks themselves, turning limestone into marble, sandstone into quartzite, and mudstone into slate through processes that happen deep underground where pressure and temperature work together like artists sculpting a masterpiece. These metamorphic rocks, born from the marriage of pressure and heat, often show beautiful patterns and colors that speak to the intensity of the forces that created them, swirling bands of light and dark that look like frozen music, crystals that grew slowly in the crushing darkness, textures that tell of rebirth through trial. Yet for all their majesty, mountains are not permanent monuments but temporary sculptures in an ongoing dance of creation and destruction. Even as they rise, they begin to fall, worn away by wind and water, ice and time. The same forces that lift them up, the thermal currents deep in the earth, will eventually shift and change, allowing the mountains to relax, to settle, to gradually surrender their height back to the patient pull of gravity. The Appalachians, once as tall as the Himalayas, now stand as gentle, rounded hills, worn smooth by hundreds of millions of years of weather and time. As your own breathing slows and deepens, matching the rhythm of mountains rising grain by grain in the darkness, remember that you too are part of this slow sculpture of the earth. The calcium in your bones was once part of coral reefs that now rest in mountain peaks. The iron in your blood was forged in the pressure cookers of colliding continents. You are made of mountain stuff, shaped by the same patient forces that lift stone toward the stars. Tonight, as the Earth continues its ancient dance beneath you, somewhere new peaks are beginning their slow journey toward the sky, while somewhere else, ancient heights prepare to finally rest their weary shoulders and let themselves be slowly, gently worn away to sand. In the deepest, darkest places of your oceans, where sunlight has never touched the sea floor and the water presses down with the weight of entire continents, something beautiful and impossible is happening. Here, in chambers that no human eye has ever seen directly, the Earth is quietly pulling itself apart, opening like a flower blooming in slow motion, creating new ground where none existed before. This is not destruction, though it might seem so at first glance, but rather the most gentle form of creation, the birth of new ocean floor through a process so gradual and so patient that mountains have time to rise and fall while a single inch of new seafloor spreads into existence. Imagine lying in your bed and feeling it slowly, imperceptibly grow wider beneath you, new mattress material appearing along an invisible seam down the middle, pushing you and everything on one side gently away from everything on the other side. This is what happens along the mid-ocean ridges, those underwater mountain chains that snake through every ocean on Earth like the seams on a baseball, marking the places where the planet heals its own wounds by growing new skin of stone. The mid-Atlantic ridge runs down the center of the Atlantic Ocean like a 10,000-mile-long scar that refuses to close, stretching from the Arctic Ocean to the Southern Ocean in an unbroken line of creation. But this scar is not a wound, it is a birthplace, where molten rock from the Earth's deep interior rises up through cracks in the ocean floor and cools into fresh stone that becomes the newest part of our planet's surface. Every day, every hour, every moment, new Earth is being born along this ridge, spreading outward like ripples from a stone dropped into still water, carrying Europe and North America apart at the speed your fingernails grow. Picture yourself descending through the ocean depths toward one of these underwater gardens of creation. The water around you grows colder and darker as you sink past the realm where whales sing to each other, past the layers where jellyfish drift like living constellations, down into the eternal midnight where the only light comes from the bioluminescent lanterns of creatures so strange they seem designed for alien worlds. Here, where the pressure would crush any surface dweller instantly, you would find yourself approaching one of the most active and dynamic landscapes on Earth. The ridge itself rises from the abyssal plain like an underwater mountain range, its peaks and valleys carved by forces that operate on timescales measured in millions of years. Along the crest of this ridge runs a valley, a rift that marks the exact place where the Earth is pulling itself apart. This is not a violent tearing, like fabric ripped by impatient hands, but rather a gentle opening, as if the planet were slowly exhaling and allowing space to expand between its ribs. From this central rift, molten rock, magma heated to temperatures that would melt copper, rises from chambers deep in the Earth's interior. When this liquid stone meets the crushing cold of the deep ocean, it cools almost instantly, forming pillow-shaped masses of fresh basalt that accumulate like volcanic cushions on the sea floor. This newborn rock is still warm when it solidifies, and as it cools further, it contracts slightly, creating space for the next pulse of magma to fill. The process continues with the patience of geological time, each new injection of molten rock pushing the previously formed stone a little farther away from the central rift. The ocean floor spreads outward from the ridge like a slow-motion conveyor belt made of stone, carrying with it the magnetic signature of the Earth's field at the moment each section cooled, creating stripe patterns in the rock that tell the story of our planet's magnetic history over millions of years. This spreading creates some of the most hauntingly beautiful landscapes on Earth, though few human eyes will ever see them directly. Black smokers, underwater geysers of superheated, mineral-rich water, erupt from the ridge like dark fountains, creating oases of life in the deep ocean desert. Around these vents, communities of creatures that have never known sunlight thrive on the chemical energy released by the Earth's interior, forming ecosystems so alien and wonderful that they seem like previews of life on distant worlds. Tube worms as tall as trees wave in the deep currents, their bodies home to bacteria that transform the chemistry of the vents into food. Giant clams and mussels cluster around the warm water like crowds gathering around a winter fire. Ghostly white crabs scuttle across fields of fresh lava, while fish with lights for eyes patrol territories that exist only because the Earth is generous enough to create new ground for them to inhabit. The Atlantic Ocean exists because of this process of gentle division. 180 million years ago, there was no Atlantic, just the supercontinent Pangaea, with Europe pressed against North America and Africa nestled beside South America like pieces of a completed jigsaw puzzle. Then the Earth began to stretch and open along what would become the Mid-Atlantic Ridge. At first, there was just a narrow rift valley, like the Great Rift Valley that runs through eastern Africa today. Slowly, this rift filled with water, then widened into a narrow sea, then expanded into the ocean that now separates the Old World from the New. Every inch of the Atlantic Ocean floor tells this story of gradual separation. The oldest parts of the Atlantic seafloor lie along the continental margins, where the first tentative spreading created the earliest new ocean crust. The youngest parts lie along the Mid-Atlantic Ridge itself, where the process continues today, adding new stone to the planet at a rate measured in centimeters per year, slow enough that you could literally watch the ocean grow if you had the patience of a mountain. This process of seafloor spreading is happening right now in oceans around the world. The Pacific is creating new floor along the East Pacific Rise. The Indian Ocean spreads along multiple ridges that branch and diverge like the roots of some enormous underwater tree. Even the Arctic Ocean, locked beneath its cap of ice, grows new stone along the Gackle Ridge, proving that creation continues even in the planet's most remote and inhospitable places. What makes this process so remarkable is not just its scale, but its gentleness. The Earth does not tear itself apart violently, but rather opens like a meditation on the nature of growth and change. The spreading happens so gradually that it disturbs nothing, allows everything time to adjust, creates space without destroying what came before. Old ocean floor, when it has traveled far enough from its birthplace, eventually sinks back into the Earth's interior at distant trenches, completing a cycle that has been operating for billions of years. As you rest tonight, somewhere beneath the waves, new stone is cooling in the darkness, adding its tiny contribution to the slow expansion of the ocean basins. The Earth breathes outward through these underwater gardens of creation, each breath measured not in seconds but in centuries, each exhalation making room for new wonders to emerge from the deep places where fire and water meet in perfect, patient harmony. As you settle deeper into the quiet rhythm of your own breathing, imagine that the Earth beneath you breathes too, but with lungs made of stone and breath measured not in seconds but in centuries. Volcanoes are the Earth's breathing holes, the places where the planet's ancient inner fire finds windows to the surface world, releasing pressures that have been building in the darkness for thousands, sometimes millions of years. Each volcanic eruption is like a long, slow exhalation from the depths, a sigh of relief that carries with it the molten dreams of the deep Earth. Think of the Earth as a living being with a heart of iron fire, its chest rising and falling with the slow circulation of thermal currents in the mantle. Just as your own breath sometimes needs to be released in a deeper sigh when you've been holding tension too long, the Earth occasionally needs to exhale more dramatically through its volcanic vents. These are not moments of anger or violence, though they may appear so to human eyes, but rather necessary releases of energy that keep the planet healthy and balanced, part of a respiratory system that has been operating since the Earth was young. Volcanoes form wherever the Earth's inner fire can find a pathway to the surface. Sometimes this happens where tectonic plates pull apart, like along the mid-ocean ridges you learned about in your journey through the deep sea. There, magma rises easily through the widening cracks, creating underwater mountains and new seafloor with the gentle persistence of flowers growing toward light. Other times, volcanoes appear where one piece of the Earth's crust slides beneath another, carrying water and sediment down into the hot interior where they mix and melt, creating magma that is lighter than the surrounding rock and rises like bubbles in thick honey toward the surface. The most poetic volcanoes, perhaps, are those that form over hotspots, places where plumes of especially hot rock rise from deep in the Earth's interior like thermal elevators carrying fire from the core toward the surface. The Hawaiian Islands tell this story beautifully, each island a chapter in the same slow-moving tale of a hotspot breathing through the ocean floor. As the Pacific Plate drifts northwest over this stationary plume of deep heat, new volcanoes are born while older ones gradually move away from their source of fire, cooling and settling into the ocean like elderly mountains taking their rest. Picture the moment when magma first breaks through to the surface after its long journey from the depths. This molten rock has traveled through chambers and passages deep underground, sometimes pausing for thousands of years in underground reservoirs where it slowly cools and changes, mixing with other melts, incorporating fragments of the rocks it encounters on its upward journey. When it finally emerges into the world of air and water, it brings with it the chemical signature of its travels, the story of every layer it passed through, every chamber where it paused to rest. The lava that flows from volcanoes moves with a dignity that reflects the enormous patience required for its creation. Watch footage of lava flows and you will see stone that moves like thick honey, advancing with the measured pace of geological time. This is rock that remembers being liquid, that flows like a slow river of orange and red light, carrying within it temperatures hot enough to melt copper, yet moving so slowly that plants have time to wither and burn before the lava reaches them, giving life a chance to flee before the fire arrives. As lava cools and solidifies, it creates some of the Earth's newest land, fresh stone that has never felt rain or wind, surfaces that are literally being born as you watch. The big island of Hawaii grows larger every day as lava from Kilauea volcano adds new acres to its southeastern shore, creating black sand beaches and extending the island's reach into the Pacific. This is creation at its most elemental, the Earth making more of itself, exhaling stone that becomes the foundation for future forests, future homes, future dreams. But volcanoes breathe out more than just lava. They release gases that have been dissolved in the molten rock during its underground journey, water vapor that will become clouds and rain, carbon dioxide that plants will use to grow, sulfur compounds that will eventually settle into the soil to nourish future life. The early Earth's atmosphere was largely created by volcanic outgassing, billions of years of the planet breathing out the gases that would eventually make life possible. The water in your body, the air in your lungs, the carbon in your bones, all of it passed through volcanic breath at some point in the Earth's long history. Some of the most beautiful volcanic breathing happens far from human eyes, in the deep ocean where underwater volcanoes exhale their fire into the crushing darkness. These submarine eruptions create pillow lavas, rounded masses of basalt that form when the molten rock meets the cold embrace of seawater. The lava cools instantly on contact with the water, forming a skin that inflates like a balloon as more molten rock flows into it from behind. These underwater gardens of stone grow slowly in the darkness, creating landscapes of impossible beauty that exist only in the deepest places where fire and water meet. The rhythm of volcanic breathing varies from mountain to mountain, from century to century. Some volcanoes breathe continuously, like Stromboli in Italy, which has been erupting regularly for over 2,000 years, earning it the nickname Lighthouse of the Mediterranean for the glow it casts across the night sky. Others hold their breath for decades or centuries before releasing it all at once in spectacular eruptions that reshape entire landscapes and fill the sky with ash that circles the globe. Even when volcanoes appear to be sleeping, they are often just holding their breath, gathering energy for their next exhalation. Beneath the peaceful slopes of dormant volcanoes, magma chambers slowly fill and empty, thermal currents rise and fall, and the Earth's breath prepares for its next release. The timing of these breaths follows rhythms too slow for human consciousness to fully grasp, measured not in heartbeats but in the patient accumulation of pressure and heat over geological time. As your own breathing slows and deepens with approaching sleep, remember that you are part of this same planetary respiratory system. The oxygen you breathe was once part of volcanic gases. The carbon in your cells was cycled through volcanic systems. You are not separate from the Earth's breathing but part of it, connected to every volcanic exhalation through the chemistry of life itself. Tonight, as you drift toward dreams, somewhere a volcano is preparing to breathe again, gathering its strength in chambers of stone and fire, ready to release pressures that have been building since before your grandparents were born. Yet what happens when this ancient breathing suddenly stops, when the Earth's exhalations fall silent and the pressure begins to build with nowhere to go? As your body settles into the deep stillness of approaching sleep, let your imagination wander to a moment that has never happened in the 4.5 billion year history of your planet, the moment when the Earth's restless motion would finally cease. Picture the thermal currents in the deep mantle, those rivers of molten rock that have been flowing since before life began, gradually slowing like honey cooling on a winter morning. Feel the great conveyor belts of stone that carry continents across the globe beginning to hesitate, to stutter, to finally stop their ancient dance as the fires that have driven them since the world was young begin to dim and fade. This is not a story that could ever truly unfold, for the Earth's motion is sustained by heat sources so vast and enduring that they will outlast the sun itself. Yet in the realm of imagination, where time bends and possibilities bloom like flowers in impossible gardens, we can explore what would happen if the planet's geological heart suddenly grew still, if the forces that have shaped every mountain, every ocean, every grain of sand in your world were to pause like a clock winding down, leaving the Earth frozen in a moment of perfect, eternal quiet. The first change would be invisible to human senses, detectable only by the most sensitive instruments scattered across the globe. The steady drumbeat of earthquakes that mark the boundaries between tectonic plates would begin to fade, growing weaker and less frequent as the forces that generate them lost their strength. The Great Fault Lines, the San Andreas in California, the Alpine Fault in New Zealand, the Anatolian Fault in Turkey, would feel the pressure that has been building within them for decades or centuries begin to stabilize, no longer driven by the relentless push and pull of moving plates. Along the mid-ocean ridges, those underwater mountain chains where new seafloor has been born for hundreds of millions of years, the upwelling of magma would slow to a trickle, then stop entirely. The volcanic vents that have been breathing fire into the deep ocean would fall silent one by one, their black smoke as fading to cold stone monuments to a more active time. The creatures that have thrived around these oases of chemical energy, the giant tube worms, the ghostly white crabs, the bacteria that feast on hydrogen sulfide, would face a crisis as their energy source dwindled and disappeared. The spreading of the ocean floors would halt, leaving them frozen at whatever width they had achieved at the moment of stillness. The Atlantic Ocean, which has been growing wider by about an inch each year as Europe and North America drift apart, would find its expansion permanently arrested. Ships crossing between continents would forever travel the same distance, the ocean basins locked into their current configuration like photographs capturing a single moment in geological time. But perhaps the most profound changes would occur along the boundaries where continents meet, where the patient collision of landmasses has been building mountain ranges grain by grain for millions of years. The Himalayas, still rising as India continues its slow-motion crash into Asia, would find their growth suddenly suspended. The forces that have been lifting Mount Everest higher each year, so gradually that the change can barely be measured, would vanish, leaving the world's tallest peaks frozen at their current height, no longer reaching toward the stars but instead beginning the long, slow process of surrender to gravity and weather. Without the constant renewal that comes from tectonic activity, the face of the Earth would begin to change in ways both subtle and profound. The rock cycle, that endless circulation of stone from surface to depth and back again, would break down as the conveyor belts that carry crustal material into the Earth's interior ground to a halt. Old seafloor would no longer sink into trenches to be recycled into new magma. Ancient continents would no longer be refreshed by the upwelling of material from the deep Earth. The very process that has kept the planet's surface young and dynamic would cease to operate. The consequences would unfold over timescales that dwarf human history. Mountain ranges, no longer sustained by the forces that built them, would begin their inevitable erosion without any prospect of renewal. The highest peaks would slowly wear away under the patient assault of wind and water, ice and time, their material carried away by rivers toward ocean basins that would gradually deepen as sediment accumulated in their depths. The Alps would become hills, the Rockies would flatten to plains, and eventually, over hundreds of millions of years, the entire terrestrial landscape would be worn down to a nearly uniform level, broken only by the most resistant rocks that managed to withstand the endless erosion. The chemistry of the oceans would begin to shift as well. Without the constant input of minerals and gases from volcanic activity, the delicate balance that has maintained conditions suitable for life would slowly drift toward a new equilibrium. The carbon cycle, driven in part by the weathering of rocks exposed by tectonic uplift and the outgassing of volcanoes, would lose some of its most important components. The slow circulation of water through the Earth's crust, carrying dissolved minerals from the continents to the sea, would be disrupted as the pathways created by fracturing and faulting began to seal themselves shut. Yet in this imagined world of geological stillness, there would also be a strange kind of peace. The earthquakes that have terrified and fascinated humans throughout history would become legends, stories told of a more turbulent time when the ground itself could move and shake. Volcanic eruptions would exist only in the memories preserved in stone, in the frozen lava flows and ash layers that would gradually be buried under sediment settling from the quiet seas. The magnetic field generated by the Earth's spinning iron core might continue for a while, but even this would eventually weaken without the complex interactions between the core and the mantle that help sustain it. Aurora would fade from the polar skies as the planet's magnetic shield grew thin, allowing cosmic radiation to reach the surface more freely than it has for billions of years. In this stillness, life would face its greatest test of adaptability. Species that have evolved in the dynamic environment of a geologically active planet would need to adjust to a world of permanence, where the slow recycling of nutrients through rock weathering and volcanic renewal no longer operated. Evolution itself might slow, no longer driven by the changing geography that has isolated populations and created new ecological niches for millions of years. As you breathe slowly in the darkness, feeling your own circulation carrying warmth and life through your body, imagine this world where the great circulation systems of the earth have fallen silent, where the oceans no longer spread and the mountains no longer grow, where the only motion left is the patient settling of sediments in seas that will never again know the birth of new islands or the opening of new basins. In this imagined world where the earth's great dance has fallen silent, the oceans would find themselves transformed in ways both beautiful and haunting. Picture the vast blue expanses that cover most of your planet's surface suddenly trapped within basins that can no longer change their shape, no longer expand or contract with the slow breathing of tectonic motion. The seas would become like water held in cupped hands that can never open wider, destined to grow deeper and darker as the continents around them slowly surrender their substance to the patient hunger of erosion. Without the spreading of seafloors that has been creating new ocean bottom for hundreds of millions of years, the character of the deep sea would begin to shift in profound ways. No longer would fresh basalt emerge from mid-ocean ridges to form new underwater mountains and valleys. The abyssal plains, those vast underwater deserts that stretch between continents, would become increasingly isolated from the forces that have shaped them, settling into a stillness so complete that it would make the deepest meditation seem restless by comparison. As you rest in your bed, imagine the Atlantic Ocean, which has been growing wider since the age of dinosaurs, suddenly finding its expansion arrested. The mid-Atlantic ridge, that underwater mountain chain where Europe and North America have been slowly pulling apart, would fall silent. No more would molten rock rise from the Earth's interior to fill the gap between separating continents. The ridge itself would gradually cool and settle, its volcanic peaks slowly sinking beneath the weight of accumulated sediments, like ancient cities being buried by the slow passage of time. The Pacific Ocean, largest of all the Earth's water bodies, would face perhaps the most dramatic transformation. Today, its floor is constantly renewed as oceanic plates dive beneath continental margins, carrying old seafloor back into the Earth's interior while new floor spreads from active ridges. But in our imagined stillness, this great recycling system would cease to operate. The ring of fire, that circle of volcanoes and earthquake zones that surrounds the Pacific, would gradually quiet as the forces that feed it lost their strength. With no new seafloor being created and no old seafloor being destroyed, the oceans would begin a slow but inevitable process of deepening. The continents, no longer held up by the buoyant forces of tectonic activity, would start their patient surrender to erosion. Mountain ranges would wear away grain by grain, their substance carried by rivers toward the sea. Without the counterbalancing uplift that has kept landmasses above water for billions of years, the very foundations of the continents would slowly sink under their own weight. Century by century, millennium by millennium, sediments from the eroding land would accumulate in the ocean basins. But unlike today's world, where the constant motion of tectonic plates creates new shallow seas and coastal plains, these sediments would settle into basins that could only grow deeper. The ocean floors would become the final resting place for entire mountain ranges, their peaks and valleys ground down to sand and mud by the endless work of weather and water. Picture the Mediterranean Sea, that beautiful body of water that has opened and closed multiple times in the Earth's history as Africa and Europe dance their slow geological waltz. In our motionless world, this sea would find its fate sealed by whatever configuration the continents held at the moment of stillness. If it remained open, it would gradually deepen as sediments from the surrounding lands filled its basin. If it were closed off from the Atlantic, it might slowly evaporate under the Mediterranean sun, leaving behind vast deposits of salt and gypsum like those that mark its ancient dry periods. The deep ocean trenches, those gashes in the seafloor where oceanic plates normally dive beneath continents, would become permanent features of the underwater landscape. The Mariana Trench, deepest point in the world's oceans, would no longer be maintained by the active subduction that created it. Instead, it would slowly fill with sediment settling from above, like a deep well gradually being filled with sand. Yet even as it filled, the surrounding ocean basin would deepen even faster, creating new abyssal depths that would dwarf any canyon that exists today. In this deepening ocean, the chemistry of seawater would slowly change. Without the constant input of minerals from underwater volcanic activity, the delicate balance of salts and nutrients that makes the ocean a cradle for life would shift toward a new equilibrium. The circulation patterns that carry warm water toward the poles and cold water toward the equator would gradually weaken as the temperature differences that drive them lessened. The great conveyor belt of ocean currents that distributes heat around the planet would slow like a clock winding down. The coral reefs, those underwater gardens that depend on shallow, sunlit waters, would face a crisis as their foundations slowly sank beneath the growing depth of sediment. The brilliant ecosystems that flourish in the thin layer of ocean where light can penetrate would find themselves gradually pushed upward as their bases were buried, or slowly extinguished as the clear waters became clouded with the constant rain of particles from the eroding continents. Yet in this transformation, there would also be a strange kind of beauty. The ocean floors would become vast libraries of the Earth's history, their sediment layers preserving the story of every mountain that ever existed, every river that ever flowed, every creature that ever lived in the seas. Future geologists, if any existed in this stillness, would find in these deep sediments a more complete record of the Earth's past than has ever been preserved before, written in layers of mud and sand that settle with the patience of geological time. The tides would continue their eternal rhythm, pulled by the unchanging dance of moon and sun, but they would wash against coastlines that would slowly sink beneath the waves. Islands would disappear one by one as they lost the volcanic forces that created them and succumbed to erosion and rising sea levels. The map of the world would slowly simplify as peninsulas became islands, islands became shoals, and shoals disappeared beneath the deepening waters. As you feel your own breathing slow to match the rhythm of imagined waves lapping against shores that sink so slowly that centuries pass between each inch of loss, consider how this vision of oceanic stillness reflects the nature of change itself. Even in motionlessness, transformation continues, following different rules but never truly stopping, like the way your own body continues its vital processes even in the deepest sleep. In this world of deepening seas and settling sediments, the ancient mountains would find their final rest in abyssal depths so profound that they would create new categories of darkness, chambers of water where pressure reigns supreme and silence has weight. In this imagined world where the Earth's motion has ceased, perhaps nowhere would the consequence of stillness be more poignant than in the mountains themselves, those magnificent sculptures of stone that stand as monuments to the patient power of geological forces. Picture the great ranges of the world caught in a moment of eternal suspension, like dancers frozen mid-leap, their upward reach suddenly arrested at whatever height they had achieved when the Earth's great dance finally stopped. The Himalayas, still growing today as India continues its slow collision with Asia, would find themselves paused in their ancient aspiration toward the stars, their peaks left forever reaching toward heights they would never quite achieve. Imagine the Rocky Mountains, the Alps, the Andes, all the world's great ranges, suddenly finding themselves cut off from the forces that birthed them. For millions of years, these mountains have been sustained not just by the initial collision that created them, but by the ongoing pressure of converging continental plates, the constant push that has kept them rising even as erosion worked to wear them down. Without this continuous renewal, without the deep forces that have been lifting them grain by grain toward the sky, these mighty peaks would become like flowers cut from their roots, beautiful still, but no longer able to grow. The process of mountain building that you learned about earlier, that slow, patient folding and lifting of rock layers under enormous pressure, would cease entirely. The great thrust faults where older rocks have been pushed up and over younger ones would lock in place, their motion frozen like a photograph capturing a single moment in deep time. The very forces that have been sculpting the Earth's surface for billions of years would simply stop, leaving behind a landscape caught between what it was and what it might have become. Consider Mount Everest, that ultimate symbol of Earth's power to lift stone toward the heavens. Today, this highest of peaks continues to grow by about a quarter inch each year as the Indian subcontinent pushes northward into Asia. In our motionless world, this growth would cease entirely. The mountain would find itself fixed at whatever height it had reached, perhaps 29,032 feet, perhaps a few inches more or less, but no longer climbing toward the stars. The limestone near its summit, formed from ancient sea creatures that lived when dinosaurs roamed the earth, would remain forever at its current elevation, no longer rising on the slow escalator of tectonic uplift. Without the counterbalancing force of ongoing collision to lift them higher, all the world's mountains would begin the long, inevitable process of surrender to gravity and weather. This would not be a sudden collapse, but rather a patient settling, a slow relaxation of stone that had been held in tension for millions of years. The internal stresses that keep mountains standing tall, the same forces that cause rockslides and avalanches, would gradually release their energy through small adjustments and subtle subsidences that would play out over geological time. The process would begin almost imperceptibly. Tiny fractures in the rock, opened by the constant freeze and thaw cycles of mountain weather, would no longer be counteracted by the upward pressure of tectonic forces. Gradually, these cracks would widen and deepen, allowing water to penetrate further into the mountain structure. The chemical weathering that slowly dissolves even the hardest rock would accelerate as more surface area became exposed to the patient work of rain and snow. Peak by peak, ridge by ridge, the mountains would begin their slow retreat from the sky. The process would be so gradual that human generations could pass without noticing the change, yet over thousands and millions of years, the effects would become unmistakable. The jagged profiles that mark young, actively rising mountains would gradually soften and round as the sharp edges were worn away by wind and water. The steep slopes that speak of recent uplift would gradually gentle as gravity pulled loose material down into the valleys below. Rivers cutting through these ranges would find their work suddenly simplified. No longer would they need to carve through rock that was constantly being lifted beneath their channels. Instead, they would gradually deepen their valleys, carrying away the mountains piece by piece toward the sea. The Columbia River cutting through the Cascade Range, the Colorado River carving the Grand Canyon, the Ganges emerging from the Himalayas, all would find themselves racing downhill through landscapes that were no longer climbing upward to meet them. The glacier that crowned the world's highest peaks would play their own role in this slow dismantling. Without the ongoing uplift that has kept mountain summits in the cold, thin air where ice can persist year-round, many peaks would gradually lose their glacial caps as they settle to lower, warmer elevations. The ice that has protected rock faces from weathering for thousands of years would retreat, exposing fresh stone to the assault of freeze-thaw cycles and chemical dissolution. Yet even in this slow surrender, there would be a dignity to the mountain's fate. The hardest rocks, the most resistant formations, would persist longest, creating new patterns of peaks and valleys as softer materials eroded away around them. Ancient granite cores, volcanic necks, and metamorphic complexes would stand like islands above the gradually lowering landscape, their superior resistance to weathering allowing them to maintain their height even as the ranges around them slowly settled toward sea level. The sediment carried away from these eroding ranges would tell the story of each mountain's composition and history. Rivers flowing from the slowly diminishing Alps would carry fragments of rocks that recorded the collision between Africa and Europe. Streams emerging from the settling Appalachians would transport grains of stone that remembered when North America and ancient Europe were joined. Each particle of sand and silt would be a page from the biography of a mountain, carrying the story of uplift and pressure, heat and time, from the heights where it was born to the ocean basins where it would finally rest. The timescale of this great settling would stretch far beyond human comprehension. The youngest, steepest mountains might take tens of millions of years to lose their edge. The oldest, most stable ranges might persist as low hills for hundreds of millions of years, their ancient bones too strong to be quickly worn away. But gradually, inevitably, even the mightiest peaks would bow to the patient persistence of weather and time. As you rest in the darkness, breathing slowly and deeply, imagine these great stone monuments to the Earth's creative power gradually relaxing their reach toward the stars, settling back toward the level of the sea with the same patient rhythm as your own body settling into sleep. In this vision of surrender, there is no tragedy, only the natural completion of a cycle that began with uplift and finds its rest in the gentle democracy of erosion. But what of the volcanoes in this stillness, those mountains born not from collision but from the Earth's inner fire, would they too fall silent, their pathways to the deep heat sealed forever by the motionless crust above? In the profound stillness of our imagined world, where the great tectonic dance has ceased and the continents no longer drift across the globe, the volcanoes would face perhaps the most poignant transformation of all. These breathing holes of the Earth, these ancient windows through which the planet has exhaled its inner fire for billions of years, would find themselves slowly, inexorably sealed by the very stillness that has claimed the world above. Like a person holding their breath until their chest aches with the pressure of unexpressed air, the Earth itself would begin to hold its volcanic breath, with consequences both beautiful and profound. Picture the volcanic landscapes you know, the gentle slopes of Hawaii where lava flows like rivers of light, the dramatic peaks of the Cascade Range standing sentinel over the Pacific Northwest, the fire mountains of Indonesia rising from tropical seas like monuments to the Earth's creative power. In our motionless world, these volcanoes would gradually fall silent, not because the fires beneath them had died, but because the pathways that connect the surface to the deep heat would slowly close like healing wounds. The process would begin subtly, almost imperceptibly. Without the constant motion of tectonic plates to fracture and refracture the Earth's crust, the cracks and fissures that allow magma to rise from the depths would begin to seal themselves. Rock has a memory of its own. Under pressure, it flows and adjusts, closing gaps and healing fractures with the same patient persistence that created them. The magma chambers that lie beneath active volcanoes, those reservoirs of molten rock that have fed eruptions for thousands of years, would find their connections to the surface world growing tenuous, then thin, then finally closed entirely. Yet the fire beneath would not simply vanish. Deep in the Earth's interior, the same radioactive decay that has powered the planet's heat engine for over 4 billion years would continue its slow, steady release of energy. The molten iron core would keep spinning, generating heat through friction and magnetic currents. The temperature differences that drive convection in the mantle would persist, creating thermal currents that rise and fall through the viscous rock like invisible rivers of warmth. But all of this energy, all of this heat, would find itself increasingly trapped, unable to escape through the traditional channels that have served as the Earth's pressure relief valves for eons. Imagine the frustration of a deep breath that cannot be exhaled, the tension of energy that has nowhere to go. Beneath the volcanic fields of Yellowstone, that vast caldera where a supervolcano has slept for over 600,000 years, the magma chamber would continue to receive heat from below while losing its ability to release pressure above. The molten rock would slowly accumulate, growing in volume and temperature as it pressed against the increasingly solid barriers of the cooling crust above. The great volcanic chains that mark the boundaries between tectonic plates would become monuments to a more active time. The ring of fire around the Pacific, where oceanic plates once dove beneath continents in an endless cycle of destruction and renewal, would gradually cool and solidify. The volcanic peaks that have long stood as landmarks for navigators, Mount Fuji in Japan, Mount Rainier in Washington, the volcanoes of the Aleutian Islands, would slowly lose their connection to the thermal engines that built them, becoming ordinary mountains subject only to the patient work of erosion and time. But perhaps the most profound changes would occur in the ocean depths, where underwater volcanoes have been the primary architects of new seafloor for hundreds of millions of years. The mid-ocean ridges, those submarine mountain ranges where fresh basalt has emerged from the Earth's interior in an endless procession of creation, would find their volcanic vents slowly clogging with cooled rock. The black smokers that have supported unique ecosystems in the deep ocean would gradually fall silent, their chimneys of mineral deposits becoming fossilized monuments to a time when the Earth breathed freely through its underwater wounds. The creatures that have evolved to thrive around these volcanic oases would face an unprecedented challenge. The giant tube worms, the ghostly white crabs, the bacteria that convert volcanic chemicals into the energy of life, all would find their world slowly changing as the thermal vents that sustained them grew cool and quiet. Some might adapt, finding new sources of chemical energy in the slowly settling ocean depths. Others might migrate to the few remaining active sites, crowding into ever smaller refuges of warmth and chemical abundance. Yet even in this silence, the volcanic regions would retain a strange beauty. The lava flows that once glowed like rivers of liquid starlight would cool into fantastic sculptures of stone, their surfaces preserving the exact moment when the Earth's breath was held. The volcanic bombs and ash falls that once spoke of explosive release would settle into layers of rock that told the story of the last great exhalations, like fossil breath frozen in stone. In some places, the trapped energy might find unexpected outlets. Geysers and hot springs, those gentler expressions of the Earth's internal heat, might persist longer than their more violent volcanic cousins. The thermal features of Yellowstone, the geysers of Iceland, the hot springs of Japan might continue their rhythmic breathing for centuries or millennia after the last volcanic eruption, using groundwater as a medium to carry heat from the depths to the surface in a process more gradual and sustainable than the dramatic release of volcanic eruptions. The pressure building beneath the sealed volcanoes would create its own form of geological tension, a stored energy that would wait with the patience of stone for some future release. Perhaps earthquakes, those sudden adjustments in the Earth's crust, might occasionally crack the seal and allow brief moments of volcanic breathing. Or perhaps the trapped energy would express itself in the slow deformation of the landscape, creating gentle domes and bulges as the pressurized magma below pushed upward against the weight of the solidifying crust above. The chemistry of the atmosphere would slowly change as well. Without the constant input of volcanic gases, water vapor, carbon dioxide, sulfur compounds, that have helped regulate the Earth's climate for billions of years, the delicate balance that maintains conditions suitable for life would gradually drift toward a new equilibrium. The oxygen in the air, no longer balanced by volcanic emissions, might slowly increase, while the greenhouse gases that help keep the planet warm might gradually decrease as they were absorbed by rocks and oceans without being replenished from below. Yet in this imagined silence, there would also be a profound peace. The earthquakes that have marked volcanic regions throughout history would gradually cease. The ash falls that have buried cities and changed the course of civilizations would become memories preserved only in the geological record. The fear and fascination that volcanoes have inspired in humans since the beginning of consciousness would fade into legend, replaced by a new relationship with these sleeping mountains that hold their fire within like secrets too precious to share. As you rest in your bed tonight, breathing slowly and regularly, imagine the earth beneath you learning to hold its breath as well, its volcanic exhalations growing quiet as the great circulation systems of the planet settle into stillness. In this silence, energy waits with patience that surpasses understanding, while life itself would need to discover new rhythms in a world where the ancient breathing of stone has finally, peacefully, come to rest. But what would become of life itself in such a changeless world, where the slow recycling of elements through volcanic renewal no longer operated, where the dynamic geography that has driven evolution for billions of years had finally grown still? In this imagined world where the Earth's restless motion has finally come to rest, life would face its greatest test of creativity and persistence. For over 3 billion years, the story of life on Earth has been intimately woven with the story of geological change, species evolving in response to shifting continents, new mountain ranges creating barriers that separate populations, volcanic islands emerging from the sea to provide fresh canvases for evolution. But in our motionless world, life would need to write a different kind of story, one where adaptation occurs not in response to changing landscapes, but in the quiet spaces between permanence and possibility. Picture the great migrations that have shaped the natural world: caribou following ancient pathways across the tundra, whales navigating oceanic currents that span entire ocean basins, birds riding thermal currents above mountain ranges that rise and fall with geological time. In a world where the continents no longer drift and the ocean basins no longer spread, these migration routes would gradually become as fixed as the landscape itself. The magnetic navigation systems that guide sea turtles across vast expanses of ocean would slowly lose their relevance as the magnetic field, no longer stirred by the complex interactions between the core and mantle, began to weaken and simplify. Without the slow recycling of nutrients through volcanic activity and the weathering of newly uplifted rocks, the chemistry of life would need to become more efficient, more conservative. The phosphorus that forms the backbone of DNA, the iron that carries oxygen in blood, the trace elements that make enzymes function, all would become increasingly precious as the geological processes that have refreshed the supply of these vital materials for billions of years gradually slowed to a halt. Evolution would favor organisms that could hoard and recycle these elements with unprecedented efficiency, creating ecosystems where nothing was wasted and every atom was treasured. The deep ocean, where life first began its long experiment with complexity, would slowly transform into something resembling a vast, quiet lake. Without the constant input of minerals from hydrothermal vents and the stirring action of seafloor spreading, the chemistry of seawater would gradually shift toward the microscopic plankton that form the base of marine food webs would need to adapt to waters that became increasingly oligotrophic, pour in the nutrients that have sustained oceanic productivity for eons. Some species might evolve to become smaller, more efficient, requiring fewer resources to maintain their populations. Others might develop symbiotic relationships with bacteria that could extract nitrogen from the atmosphere or harvest energy from the dim chemical gradients that remained in the stilled ocean. On land, the cessation of mountain building would have profound effects on climate and weather patterns. The great ranges that currently create rain shadows and channel atmospheric currents would begin their slow surrender to erosion, gradually flattening towards sea level over millions of years. As these topographic barriers softened and disappeared, weather patterns would simplify, creating a more uniform climate across larger areas of the planet. Species that had evolved in isolated mountain valleys or on remote islands would find their barriers to dispersal slowly dissolving, leading to a gradual homogenization of flora and fauna across regions that had been separate for millions of years. Yet in this simplification, new forms of complexity would emerge. Without the constant disruption of geological change to reset the evolutionary clock, ecosystems would have time to develop relationships of extraordinary subtlety and interdependence. Imagine forests where every tree, every fungus, every insect had evolved together for tens of millions of years without the interruption of continental drift or volcanic catastrophe. These communities might achieve levels of integration and efficiency that dwarf anything in today's dynamic world, becoming superorganisms where the boundaries between individual species blur into a seamless web of mutual support and shared existence. The great coral reefs, those underwater cities that depend on the perfect balance of temperature, chemistry, and light, would face both challenges and opportunities in this changeless world. As the ocean basins slowly deepened and the continents eroded away, many existing reef systems would find themselves in waters too deep for the symbiotic algae that power their growth. But those reefs that survived the transition might evolve into structures of unprecedented complexity and beauty, growing without interruption for geological ages, creating underwater cathedrals of calcium carbonate that could rival mountains in their scale and grandeur. Evolution itself would need to find new rhythms in this stillness. Without the geographical isolation that has driven speciation throughout Earth's history, the formation of new species might slow dramatically. But the species that did exist would have vast spans of time to perfect their adaptations, to explore every possible refinement of form and function that their environments allowed. Birds might evolve flight so perfect that they could migrate across entire continents on a single breath of wind. Deep-sea creatures might develop senses so refined they could navigate by the faintest chemical traces in water that had not been stirred by geological forces for millions of years. The relationship between life and landscape would become more intimate and subtle than anything we can imagine today. Without the constant renewal of soil through erosion and volcanic ash, plants would need to form partnerships with fungi and bacteria that could extract nutrients from the most impoverished substrates. Entire ecosystems might evolve around the slow weathering of individual boulders, with communities of specialized organisms living out their entire evolutionary history in the thin layer of soil that accumulated around a single piece of granite over geological time. In the polar regions, where ice sheets would no longer be disturbed by the gradual drift of continents toward or away from the poles, permanent ice ecosystems might evolve that could persist for tens of millions of years. Life might find ways to thrive in the interface between ice and rock, creating communities adapted to conditions of such stability that they could evolve crystal-like precision in their relationships with their environment. The fossil record of this changeless world would tell a different story than the one preserved in today's rocks. Instead of documenting the rise and fall of species in response to changing environments, it would show the gradual refinement of forms over unprecedented spans of time. Paleontologists of the far future might find lineages that persisted unchanged for hundreds of millions of years, achieving such perfect adaptation to their stable environments that further evolution became unnecessary. As you rest in the gathering quiet of sleep, imagine this world where time moves differently, where change occurs not through the dramatic upheavals of a dynamic planet but through the patient accumulation of tiny improvements over spans of time that make mountains seem like mayflies. In such a world, life would become the master of its own destiny in ways that are impossible on our restless Earth, yet perhaps in this mastery, it would discover that stillness itself contains its own profound forms of beauty. As you settle into the deepest layers of rest, your breathing growing slow and regular as a tide that has found perfect rhythm with the moon, let your mind drift toward the profound beauty that would exist in our imagined world of geological stillness. In this place where the Earth's great dance has finally come to rest, where mountains no longer rise and continents no longer wander across the globe, there would emerge forms of wonder that our dynamic planet has never had the patience to create. Like the intricate patterns that frost makes on a window when the air grows perfectly still, or the delicate crystals that form only in the quietest depths of caves, this motionless Earth would give birth to beauties that require the gift of infinite time and perfect peace. In the absence of earthquakes and volcanic eruptions, of mountain building and sea flue spreading, the smaller forces that shape the world would finally have their chance to speak. Wind and water, those patient sculptors that work grain by grain and drop by drop, would become the primary artists of the landscape. Over millions of years of uninterrupted work, they would carve formations of such delicate beauty that they would seem more like music made visible than mere stone. Imagine arches and spires, canyons, and hoodoos carved with the precision of master craftsmen who had all of eternity to perfect their art, each line and curve flowing with the mathematical grace of forces that had never been hurried, never been interrupted by the violent upheavals that mark our restless world. The rivers of this still earth would write their stories in stone with unprecedented clarity. Without the constant uplift that currently forces waterways to cut ever deeper channels, these ancient streams would have time to meander with perfect freedom, creating oxbow lakes and braided channels of such elegant complexity that they would resemble the neural networks of some vast, dreaming mind. The sediments they carried would settle in patterns undisturbed by tectonic activity, creating layers of such regular beauty that future geologists might mistake them for the work of conscious design rather than the patient accumulation of countless quiet days. In the deep ocean basins, where no new seafloor would spread and no old floor would be recycled, sediments would accumulate for hundreds of millions of years in unbroken sequence. These underwater plains of mud and ooze would become vast libraries of the Earth's history, their layers preserving every falling leaf, every microscopic shell, every grain of cosmic dust that settled from space during the long centuries of geological sleep. The story written in these sediments would be more complete and detailed than any record our dynamic Earth has ever been able to preserve, a continuous narrative stretching across eons without a single missing page. The ice sheets, no longer disturbed by the drift of continents toward or away from the poles, would grow into formations of breathtaking permanence and beauty. In Antarctica, glacier might build ice cathedrals kilometers high, their crystalline walls shaped by winds that had blown in the same patterns for millions of years. The layers within these ancient ice sheets would preserve atmosphere samples from geological ages, creating frozen chronicles of the Earth's breath that would make our current ice core records seem like brief notes in comparison to these vast symphonies of frozen time. Desert landscapes would achieve their own form of perfection in this stillness. Without the tectonic forces that currently create new mountain ranges to be worn down into fresh sand, the existing deserts would slowly evolve toward states of equilibrium where every grain had found its perfect resting place. Sand dunes would develop patterns of such mathematical precision that they would seem like natural mandalas, their curves and ridges shaped by wind patterns that had remained constant for millions of undisturbed years. The silence in these places would be so complete that it would become a presence in itself, a quality of quietude so profound that it would transform the very experience of existence. Cave systems, carved by groundwater moving through limestone with infinite patience, would grow into underground worlds of unimaginable beauty. Without earthquakes to fracture the rock or tectonic movement to alter drainage patterns, these subterranean chambers would have eons to develop formations of crystalline perfection. Stalactites and stalagmites would grow to cathedral proportions, their surfaces so smooth and regular that they would seem like works of art rather than products of simple chemistry and time. Underground rivers would carve passages of such elegant geometry that they would rival the great architectural achievements of any civilization. The night sky above this still world would slowly change as well, though in ways so gradual that they would be imperceptible to any single generation of observers. Without the magnetic field fluctuations caused by the complex interactions between the Earth's core and mantle, the aurora might fade to gentle whispers of light, creating displays of such subtle beauty that they would require new forms of perception to fully appreciate. The planet's rotation might gradually slow as tidal forces with the moon operated without the counterbalancing effects of internal geological processes, leading to days and nights of ever-increasing length, seasons that stretched across what we now think of as years. In this transformed world, consciousness itself might evolve new forms of awareness. Minds that developed in a landscape of such profound stability might learn to perceive beauties that our earthquake-accustomed senses cannot detect, the music in the growth of crystals, the poetry in the settling of sediments, the mathematics hidden in the spiral of water flowing around a stone that had remained unmoved for millions of years. These minds might discover that stillness contains its own forms of dynamism, that in the absence of obvious change, subtler forms of transformation reveal themselves like stars that can only be seen when the more obvious lights are extinguished. The beauty of this eternal rest would lie not in the absence of change, but in the presence of a different kind of time, geological time stretched so thin that it becomes almost transparent, allowing deeper patterns to show through. Like a meditation so profound that the meditator disappears into the vast stillness beyond thought, this world would transcend the restless seeking that characterizes our dynamic planet and discover the peace that comes from perfect acceptance of what is. Yet even as we explore this vision of geological quietude, we return to the truth that underlies both motion and stillness, that the earth, whether dancing or at rest, holds us with the same tender constancy. The ground beneath your bed participates in both stories, the dynamic tale of our actual planet with its restless plates and flowing mantle, and the imagined tale of perfect geological peace. In your dreams tonight, you might wander through both worlds, feeling equally at home in the creative chaos of tectonic motion and the crystalline silence of eternal rest. As sleep takes you deeper into its embrace, know that the Earth's beauty lies not in any single form it might take, but in the endless creativity that emerges from the marriage of matter and time, whether that time moves with the urgency of volcanic eruption or the patience of wind sculpting stone across a million quiet years.